Hi students, today's our topic is trends in modern periodic table. This portion comes in the chapter periodic classification of elements. In this chapter we have already discussed that elements are classified by different scientists along the time, like Lavoisier. He classified the elements into metals and non-metals. Then Doberanus triad is there, Newland's octave is there, then Mendeleev's periodic table, and then latest one is modern periodic table, and that was proposed by Henry Moseley. In modern periodic table, what are the trends of certain properties like atomic radius, valency, electropositivity, electronegativity, metallic and non-metallic nature? Okay, so we'll be starting with atomic radius. Okay, atomic radius. Listen, the question is, what happens to the atomic radius if we move along the period and down the group in a modern periodic table? We know that a modern periodic table is having a structure like this. Clear? This is the modern periodic table structure. What happens to the atomic radius if we move from top to the bottom in a group or along the period? First of all, there is a question. The question is, what is atomic radius? It's simple. What is the distance between the nucleus and the outermost shell of an atom? That is atomic radius. And how we will find out, or simply how we can compare the atomic radius of elements? It is clear. If we consider the atomic radius of first group elements, which are the first group elements? Lithium, atomic number is 3. Sodium atomic number is 11 and potassium atomic number is 19. In order to compare the atomic radius of these elements, what is the speciality of these elements? All these elements comes in same group. Okay. See, this is the first group where we can see lithium, sodium and potassium. My question is, what happens to the atomic radius if we move from top to the bottom? In order to compare the atomic radius, the very first thing you have to do is write the electronic configuration. How to write the electronic configuration, that is clear to you, right? We have already discussed that in 9th standard, grade 9. And sodium is 281 and potassium is 2881. The point is K and L, here K, L, M. There are 3 shells, here there are 4 shells, K, L, M, N. As the number of shells are increasing, their size obviously increases, right? So we can say that down the group, number of shells are getting added, getting increased. So atomic radius will be increased. Or if we consider the case of lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Listen, what happens to the atomic radius if we move from left to right? That's the next question. In order to answer that, again, what do we have to do? We have to write the electronic configuration. Let me add one thing. So, group, in group or down the group, what happens? Tell me. Down the group, atomic radius increases. That's the point you have to note. Second thing is along the period. Along the period, what happens? Listen, along the period, what happens to the atomic radius? In order to find it out, what do you have to do? Write the electronic configuration. How to write the electronic configuration? It is simple. It is simple, right? So what do you have to write? Lithium 3, 2, 1, right? Electronic configuration. Then beryllium is 4, 2, 2. Then carbon 6, 2. Sorry, boron is there. Boron 5, atomic number 5, 2, 3, carbon 6, 2, 4, then nitrogen 7, 2, 5, oxygen 8, 2, 6, then fluorine 9, 2, 7. Listen, this is the electronic configuration of lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine. Listen, if you observe properly, one thing is clear, that all are having KL, listen, all are having 2 shells, right? They are K and L. If you look at these elements, you can see that the number of shells are not increasing. If the number of shells are not increasing, you may say that atomic size will not change, because if you move from left to right, number of shells are not increasing or decreasing. But the case in a group was number of shells are increasing while you are moving top to bottom, moving from top to bottom, but this is not the case when you move from left to right. Number of shells are same, but atomic radius will decrease. You know why? Because if we move from left to right, number of shells are same, okay, only 2 shells are there, but here in the case of lithium, beryllium, boron, carbon, nitrogen and oxygen and fluorine, number of shells are 2, K and L, but their nuclear charge is increasing, right? What is nuclear charge? Here lithium is having 3 protons, beryllium is having 4 protons, boron is having 5 protons, carbon is having 6 protons. That means number of protons in their nucleus is increasing. That means in their nucleus positive charge is getting increased. So that is known as nuclear charge. So as you move from left to right, number of protons inside the nucleus getting added, getting increased. So protons will increase, that means nucleus will be more positive, so they can easily attract electrons which is having negative charge. So this nucleus, which is having more positive charge, will attract electrons so close so that the size will getting decreased. So from moving from right to left to right, number of shells are same, but positive charge is increasing or number of protons are increasing, so they can easily, the nucleus can easily attract the shells, then the size will decreases and the trend will be like this. The trend will be like this. Okay, why? Because nucleus will have more positive charge and they will attract electron closely and electrons will come closer and the size will decreases, but atomic radius will be increasing in this fashion from moving from top to bottom in a group. So what happens to atomic radius? I hope that point is clear to you. And next, so this is all about trends in modern periodic table of atomic radius. Trend is moving from top to bottom, atomic radius increases, moving from left to right, atomic radius decreases. Okay, and next one is what happens to the valency. What happens to the valency? This is very important. Valency. How to find out the valency? Just recall the concept that we have discussed in grade 10. How to find out the valency? It's easy, right? The valency can be found out by simple technique. Write the electronic configuration Na281, simple, and here we have sulfur 16286 and aluminum we are having 13283. How to find out the valency? Simple, just find out the valence electron. Valence electrons. Listen, valence electron. Valence electrons, valence electrons and valence electrons. How to find out the valence electron of these elements? Just look at the last shell, K, L, M. M is the last shell in the case of sodium, right? How many electrons are there in sodium? In the last shell of the sodium, that is 1. So that is valence electron. So number of electrons present in the last shell of any atom, it is known as valence electron. So valence electrons of sulfur is 6, here it is 3. And from this valence electron, how we will find out valency? How we will find out valency? It is also easy, right? Why? See, listen, why it is easy? Because we have already discussed and studied these things in last year, grade 9. Valency. If the electronic configuration is given, valence electrons can be easily found out, and if the valence electrons are available there, valency can be easily determined. How? If valence electrons, if the valence electrons are having less than or equal to 4, if the valence electron is less than or equal to 4, then valency will be equal to valence electron. Okay, I'll explain. Valence electron is 1, right? That is less than or equal to 4, means less than 4. If the valence electron is less than 4, then valency and valence electron will be same, so valency will be 1. Here look at the third case. Valence electron is 3, that means less than 4, right? If it is less than 4, it is 3, right? Then valency will be 3. Valency will be 3. And here valence electron is greater than 4, that is 6. So valence electron is greater than 4, then valency can be calculated by 8 minus valence electron. It is simple. So by 8 minus, what is valence electron? 6. So the answer is 2. Okay, the answer is 2. The point is valency can be easily found out. And the question is, what happens to this valency when you move from top to bottom or left to right? It's simple. I'll tell you. Listen, what is happening to valency? If you just write the electronic configuration of these elements, for example, lithium 3, then beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9. Listen, if you move from, this is the second period, right? This is the second period. If you move from left to right, this will be the trend. And what happens to the valency if you move from left to right? In order to get the trend, what do you have to do? Write the electronic configuration. It will be 2 1, 2 2, 2 3, 2 4, 2 5, 2 6 and 2 7. This is the trend. This is the electronic configuration. And we know that valence electron, I am just writing the short form VE to represent valence electron. What is the valence electron? 1, valence electron 2, valence electron 3, valence electron 4, then here valence electron 5, valence electron 6, valence electron 7. And the question is, what is the valency? As I told you, if the number of valence electron is less than 4 or equal to 4, then valency and valence electron will be same. Here it is less than 4, right? So valency will be same. Here less than 4, 2. Here less than 4, valency will be 3. Here equal to 4 or less than 4, then valency will be 4. But here valence electron is greater than 4. What do you have to do? 8 minus 5, that is 3. Here valency will be 6 is greater than 4, right? So 8 minus 6, 2. Here 8 minus 7, 1. So my question is, if you move from left to right, what is happening to valency? That's my question. What is happening to the valency? 1 2 3 4 3 2 1. It is increasing first, then decreasing. That is a trend. And what happens to the valency if you move from top to bottom? Simple. Listen, in a group, valency will be same. So the trend will be remain same. So valency, what is the trend in valency? If you move from left to right, increases first, then decreases. What happens to the valency if you move from top to bottom? Remains same. Okay, so what is the trend of atomic radius and valency is clear. And as I told you, what happens to the electropositivity and electronegativity? Electropositivity and electronegativity is connected with metallic and non-metallic nature. We know that if we move from left to right, metallic nature decreases. What happens to the metallic nature? Decreases, and non-metallic nature increases. And you can connect this metallic nature and non-metallic nature with electropositivity and electronegativity. I'll tell you. Listen, if you move from left to right, the tendency to lose electron will decreases. That means the metallic nature decreases. And if you move from top to bottom, the tendency to lose electron increases, so metallic nature increases. Okay, one by one I'll tell you what happens to the metallic and non-metallic nature. If you move from top to bottom, metallic nature increases and non-metallic nature decreases. What happens to metallic and non-metallic nature if you move from left to right? Metallic nature decreases and non-metallic nature increases. I hope the point is clear. And what happens to the electropositivity or tendency to lose electron? If you move from top to bottom, it increases. Electropositivity increases. And what happens to the electropositivity? If you move from left to right, electropositivity decreases. I hope the point is clear. The last point is electronegativity. What happens to the electronegativity? If you move from top to bottom, electronegativity decreases. And if you move from left to right, electropositivity increases. and you can expect a question like this. You are provided with element A and B. Which one is having more atomic radius? B, because down the group atomic radius increases. Or A or C, which one is having more electronegativity? That is C, right? Because A, you have to compare A and C. Left to right, electronegativity increases. So these kind of questions you can expect from the area turns in modern periodic table, and this is important. Just go and do maximum questions. Okay, bye.